In the previous sections, we've talked about proportions and ratios. Here we're going to be solving them, and we do that by using cross multiplication. This is probably new to many of you, so this is one of those skills that you need moving forward, and it may be hard to give up some of the processes that you've used before. You may be kind of comfortable with them, and while they might still work here for a bit, it's going to get extremely difficult if you don't start using the cross multiplication. My consistent message on that is to make sure when you're practicing, you're using the new tool. It's low stakes, right? And it gives you an opportunity to try the new one and then check it by using what you're more familiar with. So cross multiplication is how we're getting rid of denominators. You know that you can use cross multiplication when you have two fractions with an equal sign in the middle. That is the only time that you can use cross multiplication. Okay, this is not cross canceling. Cross canceling happens when you have a multiplication symbol in between. So those are the things to look for your cross multiplication. Also note that the instruction says to round decimal answers to the 10th place. So we automatically know where we need to round. It goes back to the importance of making sure that you read the directions at the beginning of a test and then also read each problem instruction very carefully, because there are little things that aren't so little that are easy to miss if you don't actually take the time to really look at it. All right, so cross multiplication, we're going to take the right-hand denominator and multiply the left-hand numerator. Now, this is an intermittent step, but I want to show you what it looks like when you actually do this, right? So I multiplied 40 times 3. I still have the equal sign. If your problem starts with an equal sign, it needs to end with an equal sign. Now I multiply my 4 and x. Okay, so I need to simplify, right? This is a solving problem, so I simplify both sides. Well, the left-hand side is the only thing that requires a calculation. So I get 120 equals 4x. Now I need to get x by itself. In order to do that, I need to divide both sides by 4. And I get that x equals 30. And that is my final answer. We've been doing application problems, right? Word problems, and then these are not word problems, but it's always important to pay attention to whether you need to include a unit. So if we saw a dollar sign here, we'd include a dollar sign, right? So make sure to always, it's that another place where you always want to pause and make sure that there isn't a unit that's required. Go ahead and pause the video and try B, and then I'll go ahead and do it for you. So here again, I've got two fractions with an equal sign in between. So I need to move to my cross multiplication. So this time I'm doing my x times 2, right? So 2x equals, now I have 7 times 4. So 7 times 4. You could write it as 4 times 7, right? Remember, the commutative property of multiplication allows you to change the order on that without changing the value. So we get 2x equals 28, divide by 2, and x equals 14. All right, go ahead and do C and D, and then go ahead and watch what I do. And on C and D, I want you to go ahead and try checking your answer, because we can check these answers the way that we have any solution problem. So I'll go ahead and add the steps for checking on C and D. All right, so here I have 10 times 12, which is 120. So notice I'm not showing that middle step of what I'm multiplying, because this is what you'll see more often in keys and then as instructors are going through and teaching. Okay, so if you're having trouble understanding what needs to multiply together, go ahead and add that step that shows what you're multiplying, and then go ahead and show the result of that multiplication. So here I have 17 times 3x, which gives me 51x. Now I divide by 51, and when I do that, I get 120 divided by 51. Now you may be saying, wait a minute, why are we dividing that out and not leaving it as a fraction? Well, that's because the instruction is to round your answers to the 10th place. If we wanted fractions, you would be asked to give fully reduced fractions for your answer. Okay, so I got a very long decimal. So I have, I'm just going to write, I always write a few extra places from what I need, right? You have to always do at least one more place than where you're rounding. So in this case, we're rounding to the 10th. Well, I've got a 3 here, so I have to make sure I at least am showing the 100th. In this case, the 100th place is a 5, so that means my 3 has to go up, and I'm left with 2 3/10 for my final answer. Okay, so I said I was going to check. So think about what we've done, how we've used evaluation and substitution in the past to check these. Same thing. The problem may look, I don't know, a little messier because it's got fractions in it, everybody's favorite, but the process doesn't change. So everything is staying the same except that I'm taking the x out and putting in the number that I solved for. Now a heads up, when you have a decimal answer, if you round, it means that your answer will not be exact. That's just what happens when you round. So when I run these two calculations, it should be, if it's right, super, super close. A little tiny bit off is totally fine again because you've rounded. Okay, and this is the first time that we've had to see that in one of these checking scenarios. So I have 12 over 17 equals, okay, I've got my 3 times 2 3/10, so 6 9/10 over 10. Now, this is like when we've been placing things on number lines. We need to always have them in the same format. It's easiest if you have two fractions to go ahead and just divide those out and find the decimal values. So the left-hand side, I get 0, and let's see, I'll say, I'll take it out to the 1000th place. So now I need to see what the right-hand side is, and I get 69 hundredths. So notice those are really close, right? So that is close enough to say that yes, the answer is correct. If we'd kept all of the decimal places in as we were checking our answer, it would have come out basically exactly the same, but because we used the rounded answer the way that we were asked to, it made our answer slightly different. And it becomes more and more as you deal with exponents and things like that. Those little tiny differences in rounding can become pretty significant, but not in this case. It'll always be very close. All right, so now moving to D, which hopefully you've already tried, we're going to go ahead and multiply 2 times 13 7/10, and we get 27 4/10. Now we multiply the 15 times 1 7/10 x, so we get 25 5/10 x. Now we divide, we get 25 5/10, dividing both sides by that, and we get x equals, let's see, 27 4/10 divided by 25 5/10. That gives me another ugly decimal. I need to round to the 10th, so I need to write out to the 100th so I know what's going to happen. Well, it's a 7, so that means that it needs to round out to 1 1/10, and that is your final answer. So once again, we had to round, right? We actually rounded out quite a few places, so that means that our answer will be close, but not quite the same. So let's do that again. I'm just rewriting the original problem. I've got 1 7/10. I'm replacing the x with the answer that we got. And we're putting that over 2. So let's see. I have 13 7/10 divided by 15, which is 0. I'll take it to the 1,000th. How about that? So that is this value as a decimal. Now I'm going to do my 1 7/10 times 1 1/10, and then divide that by 2, and I get 0, and let's see, 935 thousandths. So again, pretty darn close enough to have me conclude that my answer is correct. So now this cross multiplication that we've been using, previously we did it so that we could solve for unknown variables. Now we're going to do it to check and see whether our proportions are true. So when you see the term proportion, it means that you're going to be setting something up that looks like what we have here. All right, so we're actually being asked to do 2 things here. One is to determine if the fraction is true, and the other is if it's not, or the proportion, if it's not, to change one fraction that makes the proportion true. Now in the practice problems, I have you change the numerator of the first fraction to try to figure out what fraction would make it true, okay? This will likely end up being some of these non-exact answers because, again, we're dealing with rounding, but as long as it's close, that's what's important. All right, so here we are taking 18 times 2. Well, 18 times 2 is 36, and that equals 9 times 4, which is also 36. Because both sides are equal, when you multiply them together, that means that the proportion is true. So let's go ahead and try B. Again, we're going to multiply across, and we have 3 times 5 is 15. Then we have 11 times 1 67 hundredths, and we get 18 37 hundredths. So that one is not true. Okay, so let's go ahead and play with this for a second. So if we're going to be trying to find a numerator, right, that gives us a true fraction, what I'm going to do is use equivalent fractions. So I'm actually going to switch this around, and I'm going to get, I've got my, just so it's in the same order as the equivalent fraction problems that we've done in the past. So that's the ratio that I'm using to try to determine what the other ratio needs to be. So if I know that the denominator that I need is 11, how do we figure out what we need to multiply something by to get to another number? When we've done equivalent fractions before, I always said take the number that you're getting to and divide it by the number where you're starting, and that gives you what you need to multiply by. So in this case, we're doing 11 divided by 3, which, you know, it's not a whole number, and that's okay. Again, these will be approximate because we are having to round. So what I'm going to do is go ahead and show what I would need to multiply by, but I am showing a rounded value here, but I'm keeping everything, all the decimal places in my calculator. So when I do actually run the calculation, it should be closer. So I'm going to multiply what's in my calculator, which is 3.666 going on forever. I multiply that by 1 67 hundredths, and that gives me a numerator of 6, and I'll go ahead and round that to the 100th, just so I'm consistent across the board in terms of how many places I'm using. Okay, and then you can check that by multiplying across, because if it's true, right, then when you multiply, you'll end up with the same answer. So what I'm trying to show you is that some of these tools that we've learned, like finding equivalent fractions, can be used across many contexts. You just need to get comfortable with recognizing when you can use it and when you can't. Anytime we're dealing with proportions where we're trying to figure out one portion of a ratio, you can use equivalent fractions. If you're trying to figure out a proportion like a missing value when we were doing those unit conversions or unit analysis, you can go ahead and do it here. So, it's a really nice tool to have that works across a whole bunch of things that we've been working with. All right, so let's do C here. So I'm going to multiply. I get 24 times 122, which gives me 2,928. And then I multiply 50 times 61, and I get 3,050. So again, they're not the same. They're not as far apart as the previous. Oh no, I guess they are. Percentage-wise, maybe not quite. But anyway, they're not the same, right? So that means that our proportions are not true. So if I'm trying to figure out what this fraction is, right, I'm going to flip these around, because the one that's staying the same is the 61/24. I know that my denominator is 50 because that's what I'm establishing, right? It's the left-hand numerator that I need to replace to try to get the fraction to be equal, or the proportion to be equal. So I'm going to do my 50 divided by 24, and that gives me, again, I'm going to show a rounded amount that I'm multiplying by, and then I'll actually multiply by the full value, right? So now I multiply the top by, actually that should be 0.8. Okay, so there we go, 0.808. So I multiply that by 61, and that gives me 127 and 1/10. So that is going to be the fraction that gives you an accurate proportion. All right, and for D, I'll just go ahead and do this one, and then I'll not go through the process. If you're working out of Pearson or other textbooks, they'll likely just have you do the multiply across and confirm whether they're the same. I've added the step of trying to figure out what would make the proportion true, because again, I want you to be able to see where these equivalent fraction steps can be used. All right, so for D, we're going to do 16 times 7.5, and we get 120, and that equals the 8 1/10 times 3 75/100. This one is actually a terminating decimal, so it doesn't go on forever, which means that is an exact answer. But either way, that proportion is not true. So if we would continue, right, and try to find a fraction that made it true, we would figure out how you get from 16 to 8.1, multiply top and bottom by that value, and then that gives us our new numerator.